We'll wait 1 more minute and then we'll start. Okay. All of you, please write aldehydes which do not contain any alpha hydrogen. Aldehydes which do not contain any alpha hydrogen undergo self-oxidation and reduction. Oxidation and reduction in presence of concentrated alkali. One molecule is oxidized to carboxylic acid and one to alcohol. Wait a second. Oxidized to carboxylic acid and another is reduced to alcoholic again, and another is reduced to alcohol. For example, you have formaldehyde, HCHO. So we'll take 2 moles of formaldehyde. We'll treat this with concentrated KOH. We will get aldehyde. Sorry, we will get 1 mole of alcohol, CH3OH. Plus, we will get the carboxylic acid, HCOO negative and K positive. In this case, it is not carboxylic acid. It will become carboxylic acid when we add water to it. It is not carboxylic acid, rather it is salt of carboxylic acid because we have basic condition here. Okay, so you can say that this is carboxylic acid or just the salt of carboxylic acid. Similarly, if you have benzaldehyde, conc KOH, it is going to give you benzyl alcohol, 1 carbon and then the OH because a carbon will be there. Plus it gives you potassium salt of benzoic acid, COO negative and K positive. After this, you will write electrophilic aromatic substitutions. So both aldehyde and ketones, aldehydes and ketones अदर कीटोनिक ग्रुप लिख लीजिए. Ketonic group are deactivating and meta-directing. Meta-directing. Therefore, the substitution will occur at meta position. Substitution occurs at meta position. Okay. So here we have benzaldehyde, and we can have different reagents here. So there are three reactions that you have to learn in electrophilic substitution for this benzaldehyde and also for acetophenol. Right, the first one. If you do chlorination, Cl2 in the presence of FeCl3, then you will get only one chlorinated benzene. CHO will be here and you will get chlorine in the meta position. Next is concentrated HNO3 in the presence of concentrated H2SO4. We'll get the nitro group substituted at the meta position. CHO will be as it is. Here we'll get NO2 group. The last is concentrated H2SO4. And this you will have CHO as it is. And in the meta position, we are going to get SO3H. Just to tell you guys, only this reaction is there in NCERT, तो इसको मत भूलिएगा नाइट्रो वाला, ठीक है? Right, next. Now, same type of reaction will happen for acetophenol also, okay? So please write the structure of acetophenol, just a second. Instead of CHO, you will have COCS3. This is benzaldehyde. This is acetophenol.
Sir, can you scroll up a bit?
ठीक है इतना?
Yes.
See, the structure of acetophenol, I'm just giving you the complete structure. When I write CO, this is C double bond O. And then you have CH3. ठीक है? आप लोग कोई प्लीज इस तरह से मत लिख लीजिएगा. ठीक है, ये स्ट्रक्चर नहीं है. The structure is the above one. CO means C double bond O. This is acetophenol. So till here, aldehyde, ketones, and carboxylic acid is over. No, carboxylic acid is not over. Aldehyde and ketones are over. And from here, we're going to write about carboxylic acid. Okay. So till here, you have aldehyde, ketones, and aldehyde and ketones. Now we are going to start carboxylic acid. Let me know once you're done. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Right, next. The method of preparation of carboxylic acid. Now, carboxylic acid can be prepared, if you remember, from primary alcohols and aldehydes using oxidation. Okay, so if we use oxidizing agent with primary alcohols and aldehydes, then we are going to get carboxylic acid. So the number one is oxidation of 1-degree alcohol and aldehydes. Okay, so if I take some 1 degree alcohol. And a strong oxidizing agent, I am going to get 1, 2, 3 carbons. ठीक है, 4 carbon नहीं है यहाँ पे, you have only 3 carbons, 1, 2, 3 carbon atoms, and you will get COOH. ठीक है. So what are the strong oxidizing agents that we can use? Tell me. We can use K2Cr2O7. We can also use KMnO4. And we can use one important reagent, that is CrO3 in H+. Okay, this is known as Jones reagent. ठीक है. K2Cr2O7 के बदले में आप Na2Cr2O7 भी यूज कर सकते हैं. ठीक है. So all of these are oxidizing agents, strong oxidizing agent. Right, next. Similarly, aldehydes can be converted to alcohols. Sorry, aldehydes can be converted to carboxylic acid. Using mild or strong oxidizing agent. Okay. Now mild oxidizing agent के बारे में अगर आपसे पूछे कि what is the mild oxidizing agent that we can use, that is silver oxide, Ag2O. ठीक है. mild oxidizing agent में आपके पास PCC वगैरह नहीं, PCC they do not react, those are weak oxidizing. Okay. Mild oxidizing agent that are, they don't liberate too much of heat. When you have strong oxidizing agent, उसमें क्या होता है, you get too much liberation of heat, and if you are going to use strong oxidizing agent, there is a chance that you can break carbon-carbon bond. ठीक है. mild oxidizing agent के केस में silver oxide is one of the mild oxidizing agents. Similarly, you have hydrogen peroxide, which is a mild oxidizing agent. Right, next. From alkyl benzenes. Second one. From alkyl benzenes. Now, in alkyl benzene, this is important. First of all, it doesn't matter how many carbon atoms are there in the alkyl chain length. First of all, you are going to oxidize it using KMnO4 in the presence of heat. And you will use KOH. So in this case, since we are in the basic condition, we will get COO negative and K positive. This will require acid hydrolysis to convert it to COOH. Okay, so it doesn't matter even if you have only a CS3. First step is KMnO4, KOH, and heat. Second step is H3O plus or acid hydrolysis, and you are going to get COOH. Right, the third one from nitriles and amides. From nitriles and amides. In the case of nitriles, if you have R, C triple bond N plus H2O. Now, in the presence of acid, or you can also use base, in the presence of H plus or OH negative, you are going to add water to it. Okay. So how the water adds? Nitrogen will get both the hydrogen and carbon is going to get the oxygen. So you will get R, C double bond O, and NH2. Now, once you have got amide, in order to convert amide to carboxylic acid, you need H plus or OH negative. And you are going to get H plus and OH negative in the presence of water. ठीक है, दोनों में hydrolysis ही होता है. You will get RCOOH. So basically, if you have CONH2, H3O plus and heat, then you are going to get COOH. Similarly, if you have CnO plus, second step में भी आपके पास H plus and heat, then you are going to get COOH. Okay. Now you can also get benzoic acid from this. If you have C double bond O NH2, you can just add, even if you have H2O, तब भी आप क्या बना दीजिएगा, सीधा benzoic acid बना दीजिएगा. Okay, so main thing is what? Hydrolysis. Main thing is hydrolysis should be there. There should be water molecules. If you do it in the presence of acid or base, it is going to be quicker, but main thing is hydrolysis, addition of water. Right, the fourth one. From Grignard reagent. In Grignard reagent, you have RMgX plus you add carbon dioxide. This will be in the presence of dry ether because we have Grignard reagent. So there should be dry ether, there should be no water. Now, once you add carbon dioxide, the carbon dioxide is going to be attacked by C. Carbon dioxide का structure क्या था? Oxygen, carbon, double bond oxygen. So this R negative, delta negative on the R, it is going to attack on the carbon atom like this. Okay, so you will get C, the double bond O is as it is, and you have a R group attached to the carbon of carbon dioxide. One of the oxygen gets O negative, and O negative को neutralize करने के लिए we have MgX. Then you add water. In the presence of acid, you will get R COOH. ठीक है, तो यहाँ पे आपके पास एक C double bond O था, and then you have OH. So this is also two-step reaction. If you have, let us suppose 1,2 carbon atom and MgX. First step is CO2. Second step is H3O plus. Here you are going to get C, 2 carbon atoms from Grignard reagent, third carbon atom from carbon dioxide and OOH. Okay, so here you have 2 carbon atoms and this is having 3 carbon atoms. So it is very useful for preparation of, it's very useful for the preparation of carboxylic acid with 1 extra carbon, with 1 more carbon than the reactant. Okay, for example, both the above reaction, the nitriles and the Grignard reagent, these are important reactions. For example, if you have to go from ethanoic acid, sorry, ethanol to propanoic acid. So you have addition of one carbon atom. So in this case, first of all, see what is ethanol? 1, 2 carbon atom and OH. 1, 2, 3 carbon atom and COOH. Okay, so 1, 2 carbon atom and OH and 1, 2, 3 carbon atoms and COH. Now, how to go from ethanol to propanoic acid? Please see. First of all, I will do SOCl2, convert this to alkyl halide. Then I am going to add KCN, and this will be converted to what? And this will be converted to CN. Once I have got CN, I will add H3O plus and heat, and I'm going to get carboxylic acid. So this is one way of going from ethanol to what? Ethanol to propanoic acid. Another way of going the same thing. ठीक है ना? ये first method है. Second method आप जा सकते हैं क्या? First reaction is going to be the same. SOCl2, that is going to give you Cl here. Then next reaction I'm going to do with. So how many more carbons do I need? I need only one more carbon. So I will add here MgCl first of all. I will just add magnesium here. So if I will add magnesium, there will be an insertion reaction. I will get MgCl, Grignard reagent. Then I will add CO2. And then in the second step, I'm going to add, this is the first step, second step, H3O plus. So I will get 1, 2, 3 carbon atoms and COOH. Okay. So both of these reactions are very important. If you want to go from some alcohol, some alkyl halide to a carboxylic acid with one more carbon. So if there is N plus 1 carbon atom carboxylic acid, then these reactions are very useful. So please write this down. Now instead of SOCl2, you can use any other halogenating reagent. ठीक है, but SOCl2 is the best. आप एक ही को याद करके रखिए. किसी भी चीज के लिए आप एक reagent याद करके रखिए जो आप यूज कर सके, कहीं भी यूज कर सकते हैं जिसको आप. Okay, but you should remember the other reagents also जो same product देता है. For example, PBr3, you can have PCl5, PCl3. Okay, those are also going to give you haloalkanes. Write this down. Done everyone? Yes or no? Please tell me. Done, guys?
Yes.
Right, next. From acyl halides, fifth one. Now acyl halides का भी only see in carboxylic acid, most of the reaction you just have to add water here. So acyl halides, it can be converted to carboxylic acid via two different ways. If you have R, COCl, and you just add water, then you are going to get RCOOH. But if you do this in the presence of a catalyst, that is a base, you have H2O in the presence of OH negative. So first of all, it is going to give you RCOO negative, and then you have to again add H3O plus some acid. Once you get this, the carboxylate ion, you will add acid to get RCOOH. So just the hydrolysis of acyl halide, it is going to give you carboxylic acid. Right, next from anhydrides, sixth one. In anhydrides also, we are going to do hydrolysis. First of all, what is the general structure of anhydride? We are going to use anhydrides such as R, C double bond O, oxygen atom, then again C double bond O, and there will be R dash plus H2O. So I will get two carboxylic acid units. I will get two carboxylic acid unit. One will be with R and the other will be with R dash. So we'll have R, C double bond O, OH, plus we'll have R dash, C double bond O, OH. So anhydrides, it gives 2 units of carboxylic acid. So for example, if I have let us suppose here we have 2 carbon atoms like this. So in this case, I will be getting first we have 2 carbon atoms. So 2 carbon atom and C double bond O, OH. Plus here we have 3 carbon atoms. So 3 carbon atoms, and this will be COOH. Okay, you have the C double bond O and OH. So 2 units of carboxylic acid. Similarly, you can also have something like this. C double bond OH, plus we'll get benzoic acid. Right, the 7th one. From esters. Now esters will be hydrolyzed in the presence of a particular acid. Okay, any mineral acid H plus. So if you have C double bond O, and then you have R dash in the presence of H3O plus, acidic hydrolysis. So from this fragment, you are going to get carboxylic acid. Okay, R C double bond O kar lijiye first of all, R C double bond O, and then you write OH plus R dash O H. So you get a carboxylic acid and an alcohol. This reaction you have done in the methods of preparation of alcohols also. So please write if you have something like this. So here we'll be getting 1, 2, 3 carbon atoms, that is propanoic acid plus 1 carbon atom, methanol. Benzoic acid plus methanol. Let me know once you're done. Done, everyone? Yes or no? Please tell me. Is everyone done? Okay, please write next. The physical properties. Carboxylic acid. Now, in this you will write first of all, regarding the boiling point. So please write carboxylic acid have higher boiling points. Carboxylic acid have higher boiling point than comparable aldehyde, ketones, and also alcohols. Why is this? This is due to more extensive hydrogen bonding. Okay. For example, if you have carboxylic acid, it is going to have a diene. It is going to be C double bond O OH. Okay. Another carboxylic acid, C double bond O OH. Okay. So in one molecule only, they can have hydrogen bonding in this manner. Okay. So you can see there are two hydrogen bonding per molecule of, there are two hydrogen bonding, right? This carboxylic acid is having one hydrogen bonding. This carboxylic acid is having two hydrogen bonds. So each molecule is responsible for two hydrogen bonds. But that is not the case in the case of alcohols. That is why they have more extensive hydrogen bond. And also write another point. In vapor state, in vapor form, carboxylic acid exists in dimer with structure as above. Okay, so this hydrogen bond is so extensive and so strong that अगर आप evaporate कीजिएगा carboxylic acid को, तो carboxylic acid they don't have this type of molecule. They have this type of molecule. They exist in dimer phase. So there is a question that can come in your board examination. Draw the structure of carboxylic acid in vapor phase. Okay, in vapor phase or in vapor form, in vapor state. So you are going to draw this structure, and then you will write in vapor state carboxylic acid exists as dimer. You write here. एक तो वेपर स्टेट में सवाल आता है, but in aprotic state, whenever you have a solvent which is not having any protons, then in that state also it is dimer. But आपको सवाल generally vapor form में आएगा. Okay, so this structure is present when you have carboxylic acid in vapor form, vapor state, or in aprotic solvent. Okay, please write this down. This is quite important. फ्री के मार्क्स हैं लेकिन अक्सर बच्चे भूल जाते हैं. Done everyone? Yes or no, please tell me. Done, guys?
Yeah, done, sir.
Right, next. Regarding the solubility. So you'll write. Please write your thing. Aliphatic carboxylic acid are soluble in water as they form hydrogen bond with water. How can they form hydrogen bond with water? So this is water molecule. You can have double bond oxygen ka OH and then R group. Oxygen can be in hydrogen bond with H, O, C double bond OR. Okay. This hydrogen can also be in hydrogen bond with oxygen double bond carbon, OH and R group. Okay. So all of these molecules, there are 3 atoms in water and all of them are associated through hydrogen bond with carboxylic acid. But right, solubility decreases as the number of carbon atom in alkyl chain increases. Why? Because alkyl chain is non-polar, it is not favorable for solubility. And इसी वजह से benzoic acid is not soluble in water. Benzoic acid is not soluble in water. वैसे तो carboxylic acid that is having more than 4 carbon atoms are also not very much soluble, but in general we can say that solubility होती है carboxylic acid की. तो फिर अगर benzoic acid soluble नहीं है तो पानी में तो reaction करेगा नहीं. So how can we react benzoic acid? We will react benzoic acid in the presence of organic solvent. Okay, so please write next. Carboxylic acid are also soluble. इसमें कोई आपके देखिए यहाँ पे हमने पहले aliphatic लिखा था, ठीक है, बट यहाँ पे कोई there is no limitation here. All the carboxylic acid are soluble in organic solvent such as benzene, ethers, alcohol, chloroform. Okay, these are the examples of organic solvents. Done everyone? Yes or no? Please tell me. लिख लिया आप लोगों ने?
Yes, sir.
Right, next.
Yes, sir.
Chemical properties of benzoic. Sorry, carboxylic acid. Now, in this you are going to write first of all acidic character. Now in this, first of all, the reactions with metals and different types of alkalis. Reaction with metals and alkali. So for example, if you have any carboxylic acid, general RCOOH plus active metal. What is an active metal? कौन से active metal होते हैं? छापा या फिर wedding? Which are the active metals? Tell me. छापा elements या फिर wedding elements? भूल गए. You remember छापा elements and wedding elements? Yes or no? Electrochemistry. Wedding elements are active metals. Okay, RCOH plus Na. This is going to give you RCOO negative, Na positive plus H2 gas, liberation of hydrogen. And if you have RCOOH plus NaOH, then this is going to give you R, same thing, COO negative, Na positive, the carboxylate ion, plus in this case it will be water. Then if you have NaHCO3, then this is going to give you RCOO negative, Na positive, plus carbon dioxide and water. Okay, so these are the reactions again. Then we are going to look at the strength of acidic character. Okay, acidic strength. एक तो reactions हो गए, so these are the general reactions. Sodium. All of these are going to give you only what? Carboxylate ion. Okay, sodium salt या potassium salts of carboxylate ion. Then you will have hydrogen in the case of metals, and if you have hydroxides, then it is going to be what? It is going to be water. And if you have something like bicarbonate, then it is going to be carbon dioxide, and then you have water. Okay, but the main organic product is carboxylate ion. Write this down quickly. Next thing is important, that is the acidic strength of carboxylic acid. Done everyone? Yes or no? Please tell me. Done guys? नहीं लिखिए क्या आराम से लिखिए. चलिए write next. Acidic strength. What do we have? Acidic strength. Now please see, when we have carboxylic acid, C double bond O, and we have OH. If you add water, then in this case, what is going to happen? The water, it is going to get this hydrogen atom, and they will get R, C double bond O, O negative. Now this O negative is resonance stabilized. Okay, that means this negative charge has a probability of delocalization. It can delocalize, and that is why this resonance stabilized structure is going to be the main force why carboxylic acid is what acidic in nature. So please write the point: carboxylic acid dissociate in water to give a resonance stabilized carboxylate ion to give a resonance stabilized carboxylate ion and H3O plus. H3O plus को क्या बोलते हैं? हाइड्रोनियम आयन. ठीक है. Now since it is resonance stabilized, that is why it is what it is conjugate base stable. If the conjugate base is stable, that means whatever compound we have taken, that is, it is going to be an acid. It is going to be an acid. Now, how to check the acidic strength? If I talk about the qualitative, ठीक है, qualitative बाद में लेते हैं, पहले लेते हैं quantitative. ठीक है, quantitative analysis अगर हम लें, तो that is going to be determined by the equilibrium constant. If I write the K equilibrium for this case, now K equilibrium will be equal to what? The products upon the reactant raised to their stoichiometric coefficient. So what is the product here? The product are 2 H3O plus and multiplied by the concentration of RCOO negative. Divided by what is the reactant? The reactant is RCOOH, and we have water. Now, since liquid water is not going to be added here, so ये K equilibrium से Ka कैसे बनता है? It becomes Ka if you add. Concentration of water is not changing. Okay, concentration of water is going to be the same. हमेशा एक ही होता concentration of water 55.5 moles per liter. Okay, that's not going to change. So this is also a constant. So K equilibrium multiplied by the concentration of water gives you Ka, and Ka will be equal to the concentration of H3O plus, the concentration of RCOO negative, divided by the concentration of RCOOH. Okay. Now, if the Ka is high, क्या high है आपका? If Ka is high, what does that mean? It means strong acid. ध्यान रखिए Ka बोल रहे हैं हम, ठीक है? Strong acid. It can be only possible if the numerator ज़्यादा होना चाहिए या denominator. Tell me guys. If Ka is high, then numerator will be high or denominator? What is going to be high? Tell me. If Ka, जोर से बोलिए, साफ साफ. Numerator or denominator, which is going to be high?
Denominator.
अरे डिनोमिनेटर बेवकूफ हो गए बिल्कुल आप लोग. क्या डिनोमिनेटर जब बढ़ेगा तो ये तो छोटा ना हो जाएगा कि कैसी बातें कर रहे हैं आप लोग जी. सो न्यूमरेटर इज गोइंग टू बी हाई, राइट? अरे भाई 5/4 बड़ा है या 4/5 बड़ा है? कौन सा बड़ा है? टेल मी. 1 या 2, विच इज ग्रेटर? हाँ, कौन सा बड़ा है? जल्दी बोलिए भाई. 1 या 2, which is greater? So क्या सब which is greater, 1 और 2? अरे 1 greater है ना रजान? तो न्यूमरेटर जहां पे बड़ा है वही वाला बड़ा होगा, राइट? So if K is high, then numerator is high, the magnitude of numerator is high. उसी से पता चल रहा है कि that we have H3O plus and RCO negative has been dissociated effectively. अगर ये अच्छे से dissociate होंगे तभी इनका concentration high होगा. Now K is strong, that is why it is strong acid. Now we don't use K, rather than what do we use? We use pK. क्या use करते हैं हम? pKa. Ka जनरली बहुत हाई होता है आपके पास. Ka की वैल्यू जो है ना, इट जनरली इज इन टर्म्स ऑफ लाइक 10 to the power 6, 10 to the power 7, 10 to the power 3, 10 to the power 2, इस तरह से होता है. So we don't use K, we use pKa, and pKa is minus log of K. जनरली pKa को हम लोग इस तरह से डिफाइन करते हैं, minus log of K. Now if Ka is high, in that case log Ka will also be high. If log Ka is high, then minus log of Ka will be, tell me what? अगर कोई चीज ज्यादा बड़ी है उसमें नेगेटिव साइन लगा देंगे तो ये क्या हो जाएगा? इट शुड बी डाउन, है ना? सो माइनस लॉग के अगर डाउन है तो पीके भी क्या होगा? कम होगा. सो फॉर स्ट्रॉन्ग एसिड के शुड बी हाई, पीके शुड बी लो. ओके, सो प्लीज राइट फॉर स्ट्रॉन्ग एसिड pKa is low. pKa की रेंज जनरली होती है, इट इज फ्रॉम 0 से स्टार्ट कर सकते हैं आप, 0 नहीं होगा बट 0 से स्टार्ट कर सकते हैं आप, एंड टिल 15 यू कैन टेक. ठीक है, 15 से ज्यादा भी हो सकता है, वो फिर बेसिक कैरेक्टर में बिल्कुल चला जाता है. सो द जनरल रेंज इज इफ यू हैव द pKa वैल्यू it is less than 1, then it is going to be strong acid, very strong acid. ठीक है, if it is less than 1. If the value of pKa is between 1 to 5, then it is going to be moderately acid, moderately strong acid. And हमारा carboxylic acid इसी रेंज में होता है. And if you have the pKa that is between 5 to 15, then this is going to be weak acid. If you have pKa that is more than 15, it is going to be extremely weak acid. Done everyone? Yes or no, please tell me. लिख लिया आप लोगों ने, हाँ या ना? जल्दी बताइए.
1 minute sir.
लिखिए.
Done sir.
Anyone else still writing? No? Everyone done? Okay. Carboxylic acid are obviously more acidic than alcohols, but these are also more acidic than phenols. Okay. Even though phenol, they have more number of resonating structures. So that there is a question in NCERT. Please write this down. Although phenoxide ion has more number of resonating structures than carboxylate ion, in carboxylic acid is a stronger acid than phenol. Why? ठीक है, तो यहाँ पे ना you have to put the answer in terms of carboxylic acid. तो उस पर आप ज्यादा फोकस कीजिएगा, इज स्ट्रॉन्गर एसिड. ठीक है ना? So for that is why you are also going to make the structure of carboxylate ion. आप ऐसे दिखाइएगा पहले RCOOH. In the presence of water, it gives RCOO negative plus H3O positive, and then you will show the resonating structure of carboxylate ion like this: R, C double bond O, and O negative. Here O negative is going here, and you are going to get a resonating structure that is known as equivalent resonance. Equivalent resonance क्या होता है? When you have the same charge on the same atoms. In the first case, we have the charge on oxygen. In the second case, also we have the charge on oxygen atom. You will say equivalent resonance ऐसे. बिल्कुल इसी तरह से आंसर लिखिएगा आप लोग एग्जाम के दिन, ठीक है? क्योंकि these are the crux words जिसमें मतलब टीचर ना ज्यादा चेक भी नहीं करेगा, ठीक है? अगर आपने इतना भी लिखा ना तो टीचर ऐसे टिक करके बनवा से देगा, ठीक है? प्लीज राइट इक्विवेलेंट रेजोनेंस यहीं पे, देन यू आर गोइंग टू राइट दी स्टेटमेंट. प्लीज राइट विथ मी. The conjugate base of carboxylic acid, the conjugate base of carboxylic acid, that is carboxylate ion, is stabilized by two equivalent resonance structure या resonating structure. Stabilized by two equivalent resonance structure in which the negative charge is on electronegative oxygen atom. Is on electronegative oxygen atom. But in phenoxide ion, the negative charge is at less electronegative carbon atom. Less electronegative carbon atom. And you write. Hence, carboxylate ion is more stable than phenoxide ion even when phenoxide has more resonating structures. Therefore, carboxylic acid is stronger acid than phenol. Write this down. So equivalent resonance is the most important term in this answer. Equivalent resonance आप लोग नहीं बोलिएगा, okay? All of you done? Yes or no? Please tell me. Done, guys. Yes or no? Please tell me. You might have लिखिए. चलें, can we move forward? Yes or no? Please tell me.
Yes, sir.
Right, next. Effect of substituent. This is the C part. चलिए इसमें लिखिए. Acidic strength of carboxylic acid depends on stability of its conjugate base that is carboxylate ion. ठीक है? So if we have carboxylate ion like this, C double bond O with O negative. अगर कार्बन के चेन में कहीं पे भी if you have electron withdrawing group, ठीक है, क्या आपके पास you have electron withdrawing group, then electron withdrawing group is going to pull the electrons and it is going to decrease the negative charge at oxygen. और अगर चार्ज डिक्रीज होता है then it increases the stability. Similarly, if you have electron donating group in the alkyl chain of carboxylic acid, तो वहां पे क्या होगा? It is going to increase electron donating group electron देगा, it is going to increase the negative charge at O and उसकी वजह से stability decrease हो जाएगी. Write this down. ठीक है? अगर स्टेबिलिटी बढ़ गई तो स्ट्रॉन्गर एसिड, एंड जब स्टेबिलिटी घट गई तो वीकर एसिड. Done, everyone? Yes or no? Please tell me. Is everyone done? Not done. जल्दी लिखिए. लिख लिया आप लोगों ने? नहीं लिखा. अच्छा, okay, Rehan. I will explain. How many of you know what is electron withdrawing group and electron donating group? अच्छा, how many of you don't know what is electron withdrawing group and what is electron donating group? रेज योर हैंड। इलेक्ट्रॉन विड्रॉइंग ग्रुप एंड इलेक्ट्रॉन डोनेटिंग ग्रुप कितने लोगों को नहीं पता है? अच्छा ओके रेहान, नो प्रॉब्लम, ठीक है हम समझा दे रहे हैं। देखिए रेहान, इसको अगर आपको लिखना तो आप लिख लीजिएगा, बाकी बच्चे नहीं लिखेंगे, ठीक है ना? दिस इज जस्ट एन एक्सप्लेनेशन, तो इट इज गोइंग टू बी अ बिट chaotic. For example, you have atoms like fluorine. तो fluorine क्या है आपके पास? It is very electronegative element. So fluorine, if fluorine is attached anywhere in the alkyl chain, then it is going to pull electron. If it is going to pull electron, that means it is what? It is withdrawing the electron. So it is electron withdrawing group. उसी तरह से अगर आपके पास कोई alkyl group है, CH3, so CH3 क्या है? This is more electronegative, this is less electronegative, right? If it is less electronegative, then this is going to push the electron. इलेक्ट्रॉन ये देने की काम आएगा, so this is electron donating group. Okay, this is the basic definition of electron withdrawing and electron donating group. So basically it is dependent on the electronegativity of the atom, on the electronegativity of the atom. If you have more electronegative element, then it is going to be more electron withdrawing. If it is less electronegative, it will be electron donating group. आ गया रेहान समझ में?
Yes, sir.
Okay, now write next. Electron withdrawing nature. Wait a second. Order of electron withdrawing nature or order of electron withdrawing groups. Now, if there is a phenyl group attached, तो phenyl में याद रखिए, phenyl का मतलब क्या? Benzene group attached है carboxylic acid के पास. So it is going to pull electron. Why? Because all the phenyl atoms are sp2 hybridized, and sp2 hybridized is going to be pulling electrons more electronegative. Because उसमें s orbital की characteristic ज़्यादा होती है, and s orbital is nearer to the nucleus. If it is nearer to the nucleus, it is going to get pulled more effectively. Then you have iodine, then we have bromine, then we have chlorine, then we have fluorine. After fluorine, we have Cn followed by NO2 and CF3. Okay, so please write this down. Electron withdrawing group ka order, and then you will write this question. फर्स्ट वाला देखिए, CH3 CO2H. CO2H का मतलब क्या हुआ? कार्बोक्सिलिक एसिड. सो यहाँ C double bond O OH versus C double bond O OH, and here in this carbon atom we also have a fluorine group attached. बताइए A या B, which is more acidic? Tell me. In this case, which is more acidic, A या B? सेकंड है आपके पास फ्लोरीन versus chlorine. C में you have 1, 2, 3, 4 carbon atoms. Here we have fluorine in this position. फर्स्ट स्ट्रक्चर आपके पास. सेकंड स्ट्रक्चर में आपके पास you have COOH and fluorine is in this position here. This is your A. चलिए इसमें तो आपको दिया ही हुआ है स्ट्रक्चर. टेल मी गाइस, फर्स्ट वाले में बताइए A या B, क्या ख्याल है आप लोगों का? विच इज मोर एसिडिक? अरे इलेक्ट्रॉन विड्रॉइंग ग्रुप कहाँ पे है? जहां पे इलेक्ट्रॉन विड्रॉइंग ग्रुप होगा वही वाला ज्यादा एसिडिक। टेल मी ए और बी विच इज मोर एसिडिक?
B.
ये सारा। टेल द आंसर इन चैट गाइस, जल्दी बताइए, इतना टाइम नहीं लगना चाहिए। देख के बताइए, लिख लीजिएगा बाद में। देख के बताइए, आंसर्स बताइए। ए और बी इन द फर्स्ट केस। हाँ, फर्स्ट केस में आपके पास आंसर है बी। वाई? बिकॉज देयर इज अ फ्लोरीन अटैच्ड हियर, तो दिस इज मोर एसिडिक। बी आपका ज्यादा एसिडिक है। नेक्स्ट में बताइए ए और बी। सेकंड क्वेश्चन में ए और बी, टेल मी गाइस विच इज मोर एसिडिक हियर? विच इज मोर एसिडिक हियर? टेल मी ए और बी। where do we have more electronegative element? अब ग्रुप को देखिए ना, हियर वी हैव क्लोरीन एंड हियर वी हैव फ्लोरीन। यहाँ पे आपके पास फ्लोरीन है, यहाँ पे आपके पास क्लोरीन है। ऐसे दीजिएगा आंसर 2 का ए या बी, ठीक है ना, मिक्स हो जाएगा अदरवाइज। टेल मी दोज हु हैव गिवन द आंसर, प्लीज टेल मी सेकंड में क्या होगा, ए और बी? सारा पारकर, इफ दैट वाज योर आंसर फॉर, आप फिर से आंसर दीजिए सारा पारकर, इफ यू हैव गिवन दिस फॉर द सेकंड क्वेश्चन। 2 का क्या होगा, ए और बी? टेल मी गाइस क्लोरीन एंड क्लोरीन में से विच इज हैविंग मोर इलेक्ट्रॉन विड्रॉइंग पावर? विच इज हैविंग मोर इलेक्ट्रॉन विड्रॉइंग पावर? अरे लिस्ट दिया हुआ है, देख के बताइए किसके में ज्यादा इलेक्ट्रॉन पुल करने की कैपेसिटी है। रेहान, व्हाट इज दिस? एफ। रेहान, रेहान का अलग ही आंसर है एफ। रेहान आपने तो पहले ठीक दिया था। एफ क्यों? अच्छा, फ्लोरीन लिख रहे हैं, छोटा एफ क्यों लिखा है आपने? कैपिटल एफ होता है फ्लोरीन, छोटा एफ फ्लोरीन नहीं होता है। हाँ, okay, so fluorine has more tendency to pull the electron, so this will be more acidic. Now in this case both are fluorines, here also we have fluorine and here also we have fluorine. So when you have the same electron withdrawing group, then you are going to look at the distance, which is nearer to carboxylic acid. B is nearer to carboxylic acid, so it is going to be more acidic. Why? If B is nearer to carboxylic acid, then fluorine can have more effect. Fluorine is nearer to carboxylic acid and it can pull the electron from oxygen atom more effectively if it is nearer to the carboxylic acid. So when you have two same electron withdrawing group, then the answer is going to be the one which is nearer to the carboxylic acid. In the fourth case, it is very easy. A is going to be more acidic in nature. Why? Because it has CF3 and it is CS3 here. So CF3 has more electron withdrawing capacity. Please write this down. Answers लिख लीजिए इसके। Done everyone? Yes or no? Please tell me. लिख लिया आप लोगों ने?
एक मिनट सर।
Done, sir.
ओके, हाँ लिख ली, लिखिए जो लोगों ने नहीं लिखा। डन गाइस, लिख लिया या नहीं लिखा?
डन।
Yes, sir. Done.
चलिए नेक्स्ट लिखिए। So acidic character is completed, right? Next, the second type of reaction is formation of anhydride. Formation of anhydride. So you need two molecules of carboxylic acid. For example, अगर हम ले रहे हैं ethanoic acid, so if I have CH3, C double bond O and OH, यहाँ से भी आपके पास इस तरह से H O C double bond O and CH3, ठीक है. In the presence of the reagent that you are going to use is H plus and heat, in the presence of heat, or you can also use P2O5 in the presence of heat. Both of these, what is going to happen? You are going to remove one water molecule like this. आपको क्या मिलेगा? CH3 C double bond O oxygen and then again C double bond O CH3. This is the anhydride. So this is ethanoic acid से बना है. This is what ethanoic acid. So this will be known as ethanoic anhydride. Ethanoic anhydride. ठीक है, आपको पता हो इथेनोइक एसिड को क्या बोलते हैं? एसिटिक एसिड भी, तो इसको क्या बोल सकते हैं? और एसिटिक एनहाइड्राइड. Okay, write the third one. Formation of esters. Now, in the formation of esters, you need alcohols या फिर phenols, ठीक है ना? You need ROH. You need ROH. So, for example, let's look at the reaction first. If you have R, C double bond O, H, plus you have R dash OH. In the presence of H plus, it is going to give you R, COO, R dash. Okay, the mechanism is also important. So please write the mechanism here. This is one of the mechanisms of ester जो आप लोगों को पढ़ना है. There are 8 different ways in which this equilibrium can exist, or you can have this type of reaction, depending on what are the subsequent, what is the carboxylic acid exactly, and what is the alcohol exactly. But this is one of the mechanisms which is the most prevalent one. So first of all, क्या होता है आपके पास? We have R, C double bond O, OH. In the presence of H plus, सबसे पहले, this oxygen atom is going to get protonated. So you will get R, C double bond O. You will have H, and this oxygen will get a positive charge, and here you are having OH as it is. Now this carbon atom is going to be very highly delta positive because it is attached with oxygen atom, and oxygen के पास क्या positive charge है. तो यहाँ पे R dash OH comes with its lone pair electron in oxygen atom, and this attacks on the carbon atom like this. This is delta positive. Now as soon as it attacks on this carbon atom gives the pi electron to oxygen. So you get R, C, single bond OH. Here you have one more OH. And here you get what? What are you going to get here? Here you are going to get O, which is having a bond with hydrogen and also with R. This is R dash, जो alcohol वाला. So you get a positive charge here. Now, what happens? This hydrogen atom, it gives the electron to oxygen, and you will get all of these are equilibrium steps. Okay, all of these are reversible steps. Please write this. Now, once this happens, this is going to give the electron here. You're going to get what? You're going to have R, C, the OH is as it is. Okay. And then here you have अच्छा यहाँ पे क्या होता है? This hydrogen atom gives the electron, but hydrogen को ये ले लेता है. So you get O two hydrogens like this, and here you have OR dash. Okay, once you have OR dash, this is positive charge. Yahan se you will get water molecule. H2O liberates from here, and you get the final product. That is anything happening here? Yeah, oxygen atom isko de dega. So you will get these lone pair electrons will form a pi bond like this. So you'll have R, C double bond O, H. This is positive charge, and here you have OR dash. Now, at last, what is going to happen? This H plus is going to get liberated here. Going to give electrons to oxygen atom, and you're going to get R, C double bond O, OR dash. Now, in this complete reaction, there is only work of proton. Okay, there is only work of proton. You're having only proton transfers. H plus to first of all this oxygen. Then there is only one attack of nucleophile, that is from the oxygen of alcohol to carbonyl carbon of carboxylic acid. Then there is one proton transfer, then again a proton transfer and liberation of water, and then you get one more proton transfer with ester. This is your ester. Write this down. There are few more reactions, ठीक है ना? तो खत्म ही कर देते हैं इसको. So we'll be done with this carboxylic acid part also. ठीक है? थोड़ा देर और रुक जाइए आप लोग. There are few more reactions. कुछ reactions आपने इसमें से देखे हुए हैं, कुछ reactions नहीं देखा है. Done, guys? Yes or no? Please tell me. लिख लिया आप लोगों ने? नहीं लिखा?
Done, sir.
Done. Right,
Done,
next.
sir.
Formation of acid chlorides. ये तीसरा रिएक्शन होगा, राइट? सॉरी,
It will be fourth.
फोर्थ होगा ये.
Yeah.
तो ये हमने गलत. एनहाइड्राइड ईस्टर्स. First was acid, correct. Formation of acid chlorides. Now, if you remember the halogenating reagents of phosphorus and sulfur, जो हमने haloalkane halogen में use किया था, PCl5, PCl3, SOCl2. So all of these are going to give you, if you have R, COOH in the presence of PCl5, or in the presence of PCl3, or in the presence of SOCl2. सब में क्या मिलेगा आपको? R, COCl, R, COCl, R, COCl. और फिर से हम बता दे रहे हैं आप लोगों को, जब भी हम CO लिखते हैं इसका क्या मतलब होता है? C डबल बॉन्ड O एंड देन Cl लाइक दिस. ठीक है ना? तो ध्यान रखिएगा. अल्कोहल्स के साथ था ना, तो यहाँ पे भी आपके पास OH है, OH ही रिप्लेस हो रहा है. सो इफ यू हैव PCl5, तो आपको क्या मिलता है? POCl3 plus HCl. When we have PCl3, we get H3PO3. SOCl2 में we get sulfur dioxide and HCl. The fifth reaction is formation of amides. Right. Treatment of carboxylic acid with ammonia NH3 with ammonia. It is going to give you ammonium salt which on hydrolysis which on heating liquid, not hydrolysis, which on heating gives amide. So in general, if you have RCOOH plus NH3, NH3 है आपका क्या base और carboxylic acid क्या है आपका acid. So in this case, you are going to get RCOO negative NH4 positive. इसमें आपका ये heat heat बाहर निकलेगा इससे water बाहर निकलेगा मतलब you'll get one oxygen and two hydrogens, है ना. So you'll have R C double CO, एक ऑक्सीजन निकल गया and you have NH2. ठीक है, तो इसका स्ट्रक्चर कैसा होता है, ऐसा होता है. CO लिखा है हमने, C double bond O NH2. Write some specific reaction. COOH, first में NH3, second में heat CONH2. ठीक है, इसमें there is one very important reaction, that is the formation of thalamide. Okay, thalamide कैसे बनता है, please write here. If you have COOH and COOH in the ortho position of a benzene ring, you react this with NH3. NH3 सबसे पहले react करने से दोनों के दोनों they will get salt. You will have COO NH4 positive और यहाँ पे नेगेटिव, यहाँ पे भी आपके पास क्या होगा COO नेगेटिव and NH4 positive. After that, when you are going to heat this, दोनों से क्या निकल जाएगा, दोनों से बाहर निकल जाएगा आपके पास water molecule. So you'll get H2O and this will be converted to CONH2 and this is also having CONH2. Now, after you heat even this one, then from here NH3 will be liberated. So one nitrogen and three hydrogens, two hydrogens from one nitrogen and one hydrogen from the other. So you will liberate NH3 from here, and both of these will have C double bond O. यहाँ पे बचेगा आपके पास NH और यहाँ पे भी आपके पास C double bond O NH. ठीक है, इस तरह से आपके पास एक अलग से रिंग बन जाता है which is known as thalamide. This whole structure is known as thalamide. चलिए please write this down. First heating से water, second heating से ammonia. Done, guys? Done, everyone? लिख लिया ना आप लोगों ने? Yes or no? Please tell me.
Yes, sir.
ठीक है. Right, next, reduction. So this will be sixth. Now, reduction of carboxylic acid gives you alcohol. But what are the reducing agent that you have to use? You can use two reducing agent. One is LiAlH4. So please write RCOOH. And second step, you need H3O plus water in the acidic condition to get RCH2OH. Okay. Now we can also use B2H6. B2H6 is known as diborane. But please remember, in the presence of NaBH4, the reducing agent, it does not get reduced by NaBH4. Okay, carboxylic acid does not get reduced by NaBH4. Done, guys? This is alcohol. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Right, next. Seventh reaction.
Sir, can you follow?
Decarboxylation.
Done.
Right here, sodium salts, or other salts of carboxylic acid liberate CO2, carbon dioxide, on treatment with soda lime. Okay. So what is soda lime? NaOH and CaO. So you have RCOONA, the salt. Here you have NaOH and calcium oxide. In the presence of heat, you are going to get RH. Okay, so carbon dioxide evolves kar jata hai and you get what? RH. That means alkane. So for example, if you have 1, 2, 3 carbon atoms, COOH, in the presence of NaOH, CaO and heat, आपको कितने कार्बन, एक कार्बन निकल जाएगा, कार्बन डाइऑक्साइड। ओके, RH प्लस लिख लीजिए, Na2CO3। ठीक है, यहाँ से आप कार्बन डाइऑक्साइड निकाल लीजिए, CO2 निकल जाएगा, तो क्या बचेगा आपके पास, CH3 एंड CH3। गॉट इट? प्लीज राइट दिस डाउन। Right, next. This is important. Hell-Volhard-Zielinski reaction. This will be eighth reaction. Hell-Volhard-Zielinski reaction. Okay, since this is a name reaction, please write carboxylic acid having carboxylic acid having at least one alpha hydrogen are halogenated at alpha position. First of all, what is going to happen? They are going to get halogenated at alpha position. कैसे halogenated होगा? In the presence of chlorine या फिर bromine with red phosphorus. Okay, please write are halogenated at alpha position on treatment with Br2 or Cl2 in red phosphorus. In red phosphorus. Right, next. Br2 or Cl2 red phosphorus to give alpha halo carboxylic acid. तो रिएक्शन के हिसाब से दिस इज वेरी इजी रिएक्शन. COH next to Br2 or Cl2 in presence of red phosphorus, and secondly you add water to it, you will get R CH COH and यहाँ पे आपको X मिल जाएगा. So for example, Cl2 red phosphorus water, COH is as it is, and you will get chlorine here. Oops, यहाँ पे Br लिख लीजिए. तो लास्ट रिएक्शन है वो आप खुद से करके आइएगा, इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन। ठीक है, इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन। क्या देखना रहता है इसमें, हम बता दे रहे इसमें, यू विल हैव COOH is deactivating and meta directing group। ठीक है, तो आपके पास सब्स्टिट्यूशन कहां पे होगा, मेटा पोजीशन पे होगा। सब्स्टिट्यूशन अकर्स एट मेटा पोजीशन। प्लीज राइट दिस डाउन। ठीक है, रिएक्शंस आप खुद से करके आइएगा। देयर आर ओनली 2 रिएक्शंस और एक रिएक्शन नहीं होता है। ठीक है, चलिए, देयर विल बी अ फ्यू क्वेश्चंस फ्रॉम दिस चैप्टर इन द नेक्स्ट क्लास। ठीक है, कुछ इंपॉर्टेंट सवाल है उनको हम कराएंगे, एंड देन वी विल स्टार्ट विद अमीन्स।